This call is now being recorded.
Okay, so here we have the cascade amplifier configuration, that is common source amplifier and common gate amplifier. So first of all, for the small signal analysis, what we have done is we just modeled a Norton equivalent circuit. Okay, or we can say the output equivalent circuit for this cascade configuration. Okay, so this equivalent circuit consists of a voltage controlled current source GM into VI and a parallel resistance R0. And this is the D2. Okay, now for Q1, Q2, we have source 1, gate 1, drain 1, and for Q2, we have source 2, gate 2, and drain 2. And this to the drain 2, we are connecting load. Okay, so to this terminal, we are connecting load. Now, in order to calculate the value of GM, first we are assuming that we are connecting this D2 to ground terminal. By that, we are drawing the equivalent circuit. Okay, so equivalent circuit for this configuration. Now, then after applying KCL at D1, we have obtained this equation. Okay, that is GM2 into VGS2 is equal to GM1 into VGS1. That was the first equation. Now, next is we have to apply KCL at node D2. Okay, so next step is applying KCL at node D2, that is our drain 2. Okay, that is here you can see in the circuit diagram. This is the D2 terminal. So this is D2. So now we are applying KCL to this node. Okay, so first you observe the current entering and leaving. So at this node you can see the current entering to the node is this I0, right? So this I0 is the current entering to the node, and current leaving from the node is one is GM2 into VGS2, right? And next is this current. Okay, that is current passing through the resistor R02. Okay, so we can say current entering to the node D2 is I0 and current leaving from the node is GM2 into VGS2 and the current flowing through the resistor R02. The current flowing through the resistor R02 we already parnadana, that is VGS2 divided by R02. Right? So we can write the KCL at node 2. That is, we can say current entering, that is I0, is equal to what sum of this current leaving, that is I0 equal to GM2 into VGS2 plus VGS2 divided by R02. Okay, here we go. So applying KCL at node D2, you can obtain the equation, that is I0, that is the current entering, is equal to sum of the current leaving, that is GM2 into VGS2 plus current flowing through R02, that is VGS2 divided by R02. Right. Now, from this equation, take VGS2 outside. So, in bracket, we will get GM2 plus 1 by R02. That is I02 is equal to VGS2 into GM2 plus 1 by R02. Right. Now, we already told, compared to this R1 by R02, the GM2 will be very much greater than 1 by R02. So that we can neglect the term 1 by R02. That is, we can say our I0 will be approximately equal to what? This VGS2 into GM2. Okay, this is our second equation. Also, here one can say in this first equation, you have GM2 into VGS2 is equal to what? GM1 into VGS1, right? So, VGS2 into GM2 is equal to VGS1 into GM1. So, here we can also write as I0 is equal to VGS1. Either I0 is equal to VGS2 into GM2 or VGS1 into GM1. Since this VGS2 into GM1 equal to VGS1 into GM1. Okay, that is VGS1 into GM1 is equal to VGS2 into GM2. So that we can say I naught will be equal to this two. Okay. Now our VGS1. Equation I naught is equal to VGS1 into GM1. Okay, so instead of VGS1, we can write it is what? V in into GM1. Okay, so in this equation, VGS1 into GM1, I naught is equal to VGS1 into GM1, and we have VGS1 is equal to what? Our VI. So I naught is equal to VI into GM1. Okay, or I can write I naught divided by Vi. This is equal to what? GM1. Okay, and not here. What is our GM? Actually, we have this equation I naught is equal to GM into Vi, or we can say our capital GM, that is the equivalent circuit, but we have to find this GM. This is equal to what? I naught divided by Vi. So now we have obtained I naught divided by Vi is equal to GM1, or we can say this is equal to capital GM. That is, this capital GM means it is the transconductance of the output equivalent circuit of the cascode configuration. The small letter GM1 means transconductance of this Q1. Okay, this capital letter GM means transconductance of this entire configuration, that is transconductance of this cascode configuration, that is capital GM. So by analysis, we found that this capital GM is equal to equivalent to our small letter GM1. Okay, so this is my third equation. So this was our one aim, that is to find the value of GM. So we have obtained capital GM is equal to what? GM1. Now next we have to obtain this equivalent resistance, that is R naught. Okay, so our next aim is to find this R naught. Okay, so next is to determine R naught. To determine R naught, what we have to do is we have to set input voltage to 0. That is, here we have to find the output impedance offered by this cascode configuration R naught. Okay, so we have to check the output resistance by applying a test voltage at the output terminal. That is, for that we are setting other input sources to, other voltage sources to 0. So we are making inset V input equal to 0 and connect a known voltage Vx known as test voltage. A known voltage Vx called test voltage at the output terminal. Okay, and the current drawn from Vx is Ix. Hence, we can say our R0 will be equal to Vx divided by Ix. That is, I will repeat, to determine R0 in this equation, we have to find, that is, actually our aim is to determine this സോറി, നെറ്റ്വർക്ക് ഇഷ്യൂ ഉണ്ടായിന്. ഞാൻ ഏത് പോയിന്റ് വരെ പറയുന്നവരെ കേട്ടു? ഡിസ്കണക്ട് ആയത് ഞാൻ ഇപ്പോഴും ശ്രദ്ധിച്ചു. ഒന്ന് ആരെങ്കിലും മൈക്ക് ഓൺ ചെയ്ത് റിപ്ലൈ ചെയ്യോ? കേൾക്കുന്നില്ലേ? ഹലോ, ഓഡിബിൾ അല്ലേ? ഹലോ, ഓഡിബിൾ ആണോ? ഓക്കെ, നെറ്റ് ഇടക്ക് കട്ടായിട്ടുണ്ടായിന്, ഞാൻ ഇപ്പോഴാണ് ശ്രദ്ധിച്ച്. എത്ര വരെ പറയുന്നത് കേട്ടിട്ടുണ്ടായി? ഇപ്പൊ സ്ക്രീൻ ഇല്ല. ഓക്കെ, ആദ്യം പ്രസന്റ് ചെയ്യാം. ഞാൻ നെറ്റ് കട്ടാകുന്നതിന് മുന്നേ നിങ്ങൾക്ക് എത്ര വരെ കണ്ടു? ജസ്റ്റ് ഒന്ന് കട്ടായിട്ടുണ്ടായി. നിങ്ങൾ ഏത് പോയിന്റ് വരെ എത്തിയത്? അല്ലെങ്കിൽ ഞാൻ പറയുന്നത് കേട്ടത് എത്ര വരെയാ? ആരെങ്കിലും ഒന്ന് മൈക്ക് ഓൺ ചെയ്ത് റിപ്ലൈ ചെയ്യോ? ആർ നോട്ട് ഡിറ്റർമിൻ സ്റ്റാർട്ടിങ്. സ്റ്റാർട്ടിങ് മീൻസ് ഞാൻ അതിന്റെ ഇക്വാലന്റ് സർക്യൂട്ട് വരക്കുന്നത് പറയുന്നത് കേട്ടായിരുന്നോ? ഓക്കെ, ഞാൻ അതും അടുന്നിട്ട് ഒന്നുകൂടെ പറയാം. So R not to determine, what we have to do is, ഞാൻ ടെസ്റ്റ് വോൾട്ടേജ് കണക്ട് ചെയ്യുന്ന കാര്യം പറഞ്ഞത് കേട്ടായിരുന്നോ? Vx കണക്ട് ചെയ്യുന്ന കാര്യം. ഇല്ല. ഓക്കെ, സോ ഞങ്ങൾ ആർ നോട്ട് ഡിറ്റർമിൻ ചെയ്യുന്നത് സ്റ്റാർട്ട് ചെയ്യും. ഇപ്പൊ സ്ക്രീനിൽ കാണുന്ന കാര്യങ്ങൾ നേരത്തെ പറഞ്ഞത് കേട്ടതാണോ? ആർ നോട്ട് ഈസ് ഈക്വൽ ടു വി എക്സ് ബൈ ഐ എക്സ് നോട്ട് ചെയ്താണ്. നെക്സ്റ്റ് ഈ പേജോ? ഇത് കട്ടായിട്ടുണ്ടായിരുന്നോ? ഇല്ലേ? ഇവിടെ ഒന്ന് മൈക്ക് ഓൺ ചെയ്യുമോ ആരെങ്കിലും ഒരാള്? ഞാൻ ചോദിക്കുന്നതിനൊന്ന് റിപ്ലൈ തരുമോ? കട്ടേനോ? റോഷി ഒന്ന് മൈക്ക് ഓൺ ചെയ്തേ. ഇത്രയും പറഞ്ഞു.
ആ സർക്യൂട്ടിന്റെ അത് കിട്ടിയിട്ടില്ല.
ഈ ആർ നോട്ട് ഈക്വൽ ടു വി എക്സ് ബൈ ഐ എക്സ് വരെ കേട്ടതാണ്. So R naught is equal to Vx by x. So what we have told is, we have to connect a test voltage at the output terminal. Okay. So for that we are setting this circuit one. This is the cascade configuration, and here we have to set input voltage equal to 0. Okay. Here we are applying input voltage, so we are setting input voltage equal to 0. And next we are applying a test voltage here. This is my output terminal. So here we are applying a test voltage Vx. That is, we know the value of Vx. So a known voltage is applied to the drain terminal. Okay. Then as a result of this Vx, a current Ix will flows through the circuit. Okay. And this R naught, that is the impedance, equivalent impedance at the output side, that is R naught. So this R naught is equal to what? Vx divided by Ix. So in this circuit, by determining R naught, that is equal to Vx by Ix, we can find the value R naught, right? So we have to determine this Vx by Ix value. For that, we have to consider the equivalent circuit. So in the equivalent circuit, for the cascade configuration, actually we have this similar configuration. Okay. So what is the difference is that we are making this input voltage equal to 0. That is Vi equal to 0. Equivalent circuit is same because the same configuration. Changes on the We are making Vi equal to 0 and we are connecting a test voltage at drain 2. Okay, that are the difference. So here what is happening to this equivalent circuit? Equivalent circuit same aanu nammal explain cheyyunnilla. So in this equivalent circuit we are making Vi equal to 0. Okay, so Vi equal to 0 implies this VGS1 which is equal to Vi. This will become 0. Okay, so Vi equal to 0 means VGS1 will also become 0. Okay, now if VGS1 equal to 0, what happened to this current source? This current also become equal to 0. Okay, so Vi equal to 0 results in VGS1 equal to 0. That means this VGS1 equal to 0, that is GM1 into VGS1 equal to 0. That means this current source, value of current source equal to 0. Current 0 means what? We can replace it with an open circuit, right? Open circuit aanengil current flow cheyilla. So current equal to 0 means this can be replaced with an open circuit. Okay, so this will become open circuit since Vin equal to 0. So for the corresponding to this Q1, we are left with this R01. Okay, so we have this resistor only R01. So in this equivalent circuit, if I am making Vi equal to 0, this instead of Q1 we have this R01 only. Okay, and this Q2 will be similar to this, and here we are not connecting to ground, we will be having a voltage source. Okay, so by this concept we can draw the equivalent circuit. You can see, so here for Q1, as I already told, Vin equal to 0, which implies our VGS1 equal to 0. That means our GM1 into VGS1 equal to 0. So this can be open circuited. This will be replaced by open circuit. So for the transistor, we have this R01 only. Corresponding to Q1, you will be having R01 only. Okay. So this is my source 1. Okay. And this is my drain 1. So to this drain, as we already drawn, we have to this drain, that is D1. This is same as source 2. That is source of this common gate configuration, this source 2. D1, source 2. Okay. So here you will be having that Q2, equivalent circuit of Q2. That is GM2 into VGS2 and parallel resistance R02. Okay, and to this terminal, what we are applying? Here we are applying the test voltage Vx. Right? Okay. So this is Vx. As a result, a current Ix will flows. And we can find our Rx equal to this Vx divided by Ix. And here also our gate of this transistor, that is G2, is grounded. And here you will be having VGS2. Right? Okay. So this is our equivalent circuit corresponding to this configuration. That is, now to find R0, we are connecting it. So, sorry, R0 equal to Vx divided by Ix. So, next the calculator I am writing KVL equation at this node, or we can say the voltage between this output terminal and ground. See, your path between this output terminal and ground. So we can say the applied voltage is Vx, right? So Vx will be equal to, that is between this point and ground, we are applying Vx. So that voltage is divided between this R02 and R01. Since this R02 and R01 are connected in series between this point and ground, we can say the total voltage Vx will be divided between R01 and R02. or we can say it will be equal to what? V R naught 1 plus V R naught 2. Okay, so this Vx will be equal to voltage drop across R0 2 plus voltage drop across R0 1. That is V R0 1 plus V R0 2. Now, what is this V R0 1? So, for that, you have to consider the current value. That is, here the current entering to this node is Ix, right? This Ix will divide between these two branches. Okay, so Ix is the current entering, and one part is GM2 into VGS2, and another part is the current flowing through the resistor R0 2. Okay, and here at this point, this current and this current will combine together and flow through this resistor, right? So actually, our current Ix ഇവിടെ divide ചെയ്ത് രണ്ട് പാത്തിലേക്ക് പോയി. But ഇവിടെ again എന്ത് ചെയ്യും? That will combine. So we can say the current will be equal to Ix itself. Right. For example, if Ix equal to 5 milliampere here, if the 5 milliampere here, 2 milliampere pass through this path and 3 through this path, then at this point, this 2 and 3 combine together and total 5 will pass through this R0 1, right? So we can say this Ix will enter to this node and the current will divide into these two paths. At this point, this will combine together and we can say the current flowing through R0 1 is equal to Ix itself, right? So we can say V R0 1. V R0 1 is equal to what? I into R, that is Ix into R0 1. Okay. So this will be equal to Ix into R0 1, V R0 1 plus V R0 2. V R0 2 means current flowing through R0 2 into this resistor R0 2. So what will be the current flowing through R0 2? So total current entering to this node is Ix. And current flowing through R0 2 is what? This Ix minus this GM2 into VGS2. Right. So Ix is the total current entering. GM2 into VGS2 is the current flowing through this path. So current flowing through R0 2 will be equal to what? Ix minus GM2 into VGS2. Right. This is the current flowing through R0 2. So VR0 2 is equal to Ix minus GM2 into VGS2 into R0 2. Now, you can see here, I can replace this VGS2. Actually, this VGS2, the voltage between these two terminals, right? So here, this terminal is connected to ground. Here, this terminal is also connected to ground. So we can say voltage drop across this R0 1. This will be VGS2. Or we can say this Ix into R0 1, that is the voltage drop across this resistor, will be equal to minus VGS2. See, the polarity opposite. So Ix into R0 1 is equal to minus VGS2. Or I can replace this VGS2 with minus Ix into R0 1. Okay, that is I can replace VGS2 is equal to minus Ix into R0 1. So here I can modify this equation. Ix into R0 1 plus Ix minus GM2 into, instead of VGS2, I can write minus Ix into R0 1. So minus minus a plus sound. Here it is Ix into R0 2. Clear? So here the voltage drop across this resistor R0 1, that is equal to Ix into R0 1, which is equal to minus VGS2. Okay, so I'm replacing with this value and we can obtain the expression like this. Now, in this expression, you can take Ix outside from all the terms. At the RHS, you can take outside so that we will get Vx is equal to what? I can take Ix outside. So in the first term, there will be R0 1, and in the second term, you will be having here. In the second term, Ix into R0 2 will be there. The multiply that Ix into R0 2 will be there. So while I am taking Ix outside, there will be R0 2 And in third term, if I am taking Ix outside, here Gm2 into R01 will into okay. Gm2 into R01 into R02 will be there, right? So here this will be Gm2 into R01 into R02. Okay. And now we can say Rx or Rx equal to what? Vx divided by Ix. So Vx divided by Ix is equal to R01 plus R02 plus Gm2 into R01 into R02. Okay. So here we can say in this expression, the last term dominates. So compared to last term, that is, R01 and R02 are very high values. Okay, so R01 and R02 multiplied with the GM2. That is the last term here. And that will be very much greater than this R01 plus R02. Okay, so we can neglect these terms. And we can write R0 is equal to approximately equal to GM2 into R01 into R02. This is the fourth equation. Okay, so here you can say by cascoding amplifier, that is using cascode amplifier, you can increase the output impedance by a factor of GM2 into R02. Already in R01, we can improve it to GM2 into R02. Okay, so now we can draw the equivalent. That is GM parallel to R0, and here we can take the output. Here we can say this capital GM is equal to what we have obtained is small letter GM1, and this R0 is equal to what? GM2 into R01 into R02. So this is our output equivalent circuit for the and now we have to calculate the voltage gain. So next we are going to calculate the voltage gain for this configuration. Okay. Initially, I am assuming no load condition. First case, no load condition. Okay. No load condition means I am considering this single circuit. Here we are not connecting to any load. That is here no load condition. I am assuming. So here I can say this output voltage. Output voltage will be equal to what? This capital letter GM, capital letter GM into VI into R0. Okay. Sorry, this is the GM matralla, GM into the VI. Okay. So this output voltage will be equal to what? GM into VI into R0. So under no load condition, we can write output voltage. V out is equal to minus GM into VI into R0. That is your circuit consider. Minus GM into VI into R0. That will be the output voltage. So our gain, voltage gain AV0. That will be equal to what? V out by VI. That is this minus GM into VI into R0 divided by VI. So this VI will get cancelled and we will obtain GM into R0. That will be the gain. Okay. And you can substitute here for GM and R0. So our GM is equal to small letter GM1 and our R0 is equal to GM2 into R01 into R02. Right. So our gain is equal to minus GM1 into GM2 into R01 into R02. And we can say if both transistors are identical, that is that Q1 and Q2 are identical, then we can say GM1 equal to GM2 and this R01 equal to R02. If both transistors are identical, we can say GM1 equal to GM2 and R01 equal to R02. Substitute this into this equation. What you will get is voltage gain is equal to what? Minus of square. Or we can say this is actually A0 square. That is A0 means voltage gain of a single transistor or single common source R transistor Q1 in the voltage gain ആണെങ്കിൽ we can say our voltage gain increases from A0 to A0 square by cascading. Okay, so by using, if you are using single transistor, we can say you will obtain the voltage gain A0. Now that is squared, that is we can improve the voltage gain using this cascode configuration. Okay, one more thing I have to say, that is the second case. If you are connecting a cascade current source load, okay. So next is a current source load, second case. So under no load condition, explain cheythathu. Next is we are considering a current source load. So here this is our cascade configuration. Okay, we are connecting this gate to ground, and here we are applying the input voltage. Okay, this is our Q1, Q2, and as the load, as the load, we are now connecting a current source as load. Okay, say current source with the value I. So this is we are connecting a current source load. The equivalent circuit here having GM into VI and this R0. So this is actually our equivalent circuit for this part, this cascade configuration. The equivalent circuit for this cascade configuration is GM into VI into R0. Parallel with the R0. Now we have connected a current source load. So for this current source load, as we already explained, this current source load is actually what? This current source load can be replaced with the open load already discussed. So similar to that, here you will be having a resistor. So that resistor will be there in parallel with this R0. Let us call it as R03. That is, this R03 is the parallel resistor of this current source. Okay, so practical current source in the case, the current source we can open circuit and there will be a parallel resistor R03. So this is connected to this terminal. That is, we can say this is our cascade. And minus GM into R0 parallel to R03. Okay. So replace with these values. Minus GM is equal to what? So GM is equal to GM1 and R0 is equal to GM2 into R01 into R parallel. Okay. Here also this R03 will be very less compared to this value. Okay. So this R03 will be very less. This will be greater. R03 will be less. That is, this GM2 into R01 into R02 will be greater than R03. So if these are connected, we are taking parallel combination, equivalent resistance will be almost equal to the smallest value, will be GM1 into R03. Okay. voltage gain with the current source load. Voltage gain of cascode amplifier with the current source load. Okay. Clear ആണോ cascode amplifier ന്റെ? Clear ആണോ? Okay. So, നമുക്ക് ഇവിടെ സ്റ്റോപ്പ് ചെയ്യാം. ഓൾസോ ഈ മോഡ്യൂൾ ഇവിടെ നമുക്ക് കൺക്ലൂഡ് ചെയ്യാം.